Hello, Chem II, and welcome to the next video in stoichiometry for Chapter 3. In the last video, we focused exclusively on real stoichiometry, where you were going from the mass of one substance in a balanced chemical equation to the mass of another substance in a balanced chemical equation. We're going to stretch out a little bit here and focus a little bit more on other quantities. So we've already done the mole, we've already done mass relationships, we've already done mass relations in reactions. We're going to stretch out a little bit and we're going to focus on other quantities. So we're going to take other quantities. So we've already, in this idea, we had mass, but we also knew we could measure the amount of a material in either volume, moles, or particles. So we're going to look at two different examples of how to go from something other than mass to mole to mole to mass. How do we start maybe on a different thing on the left-hand side, maybe the same, and end up not doing the same old mass to mole to mole to mass. So let's look at one. Here's one. So determine the volume of carbon dioxide produced at STP when 0.85 grams of butane reacts with an excess of oxygen. So let's come up with a plan. Let's go back and look at the plan. We're given a mass of butane. So we're given a mass of butane. So we're starting here. It's asking for the volume at STP. So we're ending up here. So what we're going to do, our plan is to go from mass to mole, to go across the mole, and then now instead of using molar mass for the last step, we're going to use the moles, the molar volume of a gas. So again, our plan would be to go from mass of butane, C4H10, to mole of butane, C4H10, to go to moles of, what did it ask for? Carbon dioxide. Moles of CO2. We can compare to anything in the balanced chemical equation. And then we're going to go to volume of CO2 at STP. So the first step is to go from mass to mole. We need to use the molar mass. So we calculate the molar mass of butane. We find it out to be 15.1222. So now grams will cancel. Then for the next step, we need to balance chemical equation. So the two substances we're talking about is butane and carbon dioxide. So it's 8:2 ratio. So we need to have a ratio such that our moles of butane will cancel. So the 2 goes on the bottom, the 8 goes on the top. Next step is now we have to go from moles to volume. And for that, we're going to use that molar volume of a gas at STP, or 22.4. And again, aligning it in such a way that moles of CO2 cancel. Now all we got to do is the math. So take 0.85 divided by 58.122 times 8 divided by 2 times 22.4. And worried about sig figs, this has 2, this has a lot. These are absolute numbers. You don't use those as exact numbers. So I won't use those in balancing and sig figs. And this has 3, so the least number is 2. So our final answer to 2 sig figs is 1.3 liters of CO2. So we can go anywhere we want to around this periodic table, around the flow chart. We can start any place on the left, volume, moles, particles, or mass. And we can go to any place we want to on the right. Again, volume, moles, particles, or mass. We can do anything we need to. Okay, so let's try another one. Let's try one more. So we've got, first I'm going to clean this up. So let's try the second one. So the second one says, how many formula units of barium sulfate are produced? So we're looking now at a product again, when 1.5 grams of barium hydroxide is reacted with an excess of sulfuric acid. So we need a plan. So we're going to end up at formula units, and we're going to start with grams. End up with formula units. So we're going to go here, and we're going to end up with formula units, which is down here. I never understand why. There it is. So we end up here, particles, That's what we want to get to. And we're going to, again, this time we're going to start with mass. So we're going to mass to mole to mole using the balanced chemical equation. And then for the last step, we're going to use Avogadro's number to get the particles. Again, if you have the concept of this mole diagram in your head, you can get around any way you want to. So back to the problem. Let's see. We want to go from barium hydroxide to barium sulfate. We want to go from barium hydroxide, so we go from mass. Come on, pen, work. Okay, we want to go from mass of barium hydroxide to mole barium hydroxide to mole of barium sulfate, and then ultimately to particles, formula units of barium sulfate. So it's always helpful to have a game plan. I would always use the flowchart as my help to have me have a game plan, because it's very easy on this to do a bunch of steps you might not have to do. So first step, to go from mass to mole, we need the molar mass of barium hydroxide. So we calculate that and find out that that is 171.342 grams per mole. And now grams of barium hydroxide cancels. Now I need to use my balance equation. Well, luckily in this case, it's a 1-to-1 ratio. All of them are, well, there's a 2 there. It's a 1-to-1 ratio, so it's just 1-to-1. But now my barium hydroxide cancels. There's missing a 2 there. And then finally, last step is now I need to go from moles to particles. Remember from the first video, in order to go from moles to particles, we use Avogadro's number. And there we're going to use 6.02 times 10 to the 23rd formula units of barium sulfate for every mole of barium sulfate, so that moles of barium sulfate will cancel. We do the math. Start with the 1.25 divided by the 171 times 1 divided by 1, just for giggles, and then times the 6.022 times 10 to the 23rd. And when I do that, I look at sig figs. This has 3, this has 6, infinite, and then this should really be 2, but it has 4. So I need 3. So I do the math, I round to 3 sig figs. My final answer is 4.39 times 10 to the 21st. So essentially this video shows you how it doesn't have to be, even though your textbook kind of focuses on mass to mass relationships, it can be anything. Mass, mole, particles, volume, start with one, end with a different one, but you can use the balanced chemical equation in the middle to get between the two. So next video, we're going to focus on what I mentioned very, very briefly in the last video by saying, well, what if they give you information about more than just one substance? What do you do then? So until then, everybody stay safe. I'll see you in synchronous time. And yeah, toodles.